In previous video, we have talked about context-free grammar. We know that all regular grammars are subset of context-free grammar, or regular languages are subset of context-free languages. Regular languages we can represent using finite automata or regular expression. So we can always convert finite automata or regular expression into context-free grammar. So in this video, we will see how we can convert finite automata into context-free grammar. Consider this finite automata. We have to write down productions or the context-free grammar for this. There is a very simple rules. On left hand side of the production, we have to write down source state. On right hand side, we have to write down the destination state, and we have to also add the symbol on which transition has happened. For example, from state A, we are moving to state B on reading symbol A. So we will add production like this, that from capital A, if we read small a, then we are going to capital B. So A gives AB. Now there is no other transition from state A. So A is done. Now from capital B, there are two transitions. One is on input A, one is on input B. So we have to add two transitions. On input A, it would be B gives AB, because from B, if we read symbol A, we are remaining on same state, that is capital B. So that implies to B gives AB. When we read symbol B from capital B, we are going to state C. So that transition we can write using B gives BC. Whenever transition is leading to final state, then we also have to add one additional production. That will be simply B gives B. So whatever symbols we are reading and going to the final state, that symbol production we have to add. So from state B, if we read B, we are going to the final state. So third production we have to add in that case. From capital C, there are two arcs. So we will add two productions, plus on reading B, it is going to the final state, because C is a final state. So there will be three transitions for capital C. On reading B, it is remaining on same state. So we will add the production C gives BC. On reading A, it is going to state B. So that will be C gives AB. And on reading B, it is going to final state. C is a final state. So whenever any transition leads to final state, we have to apply we have to add the production C gives and the symbol which leads to the final state, that is B. So this set of production is for the given FA. The short notation we can represent in this way, because there are three transitions for B, three transitions for C. So instead of writing individual transitions, we can separate, or instead of writing individual productions, we can separate the productions by vertical pipe. Consider the second example, where we have to write down productions or the grammar for the finite automata given on left side. Here, initial state is the final state. That means epsilon will also be the part of language. So whenever this is the scenario, we have to add one additional production. A implies epsilon, because whenever we are in initial state, it is also final. That means epsilon is acceptable. So this production we have to add. Rest of the procedure is as it is. When we read B from state A, it is going to final state. So we will add A gives B. And we have two more transitions for A. That on reading B, we are coming to state A. And on reading A, we are going to state B. From B, there are two transitions, A and B. So two transitions we have to add, plus on reading A, it is going to final state. So third transition we have to add for that. So when we read B from capital B, we are remaining on same state. When we read small a from B, we are going to capital A. And on reading A, we are going to the final state. So we have to add the production B gives A. And this we can represent in short form like this. A is having 4 productions and B is having 3 productions. Consider this example. From A, we have 2 transitions. None of them is going to final state. So we have to write down only 2 productions for A. On reading 0, it is remaining on state A, and on reading 1, it is going to state B. That's it. From B, we have 2 transitions, but one transition is leading to final state. So we have to add actually 3 transitions for B. On reading 1, it is remaining on state B. On reading 0, it is going to state C. And as state C is final state, we have to add only B gives 0. From C, we have two transition. One is on A, one is on B, and none of them are final. So we have to add only two transitions for state C. On reading 1, it is going to B, and on reading 0, it is going to A. And that's it. And this is the short notation for the given productions. And this grammar will produce all the strings which are produced by finite automata. So this is how we can convert any FA into context-free grammar. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.